Okay, so we've been talking about section 3.3 and 3.4 together. Okay. Just to remind you of the key concepts we have been talking about, we introduced the Heaviside step function, which is either 0 or 1, depending on whether the term is active or inactive. Okay. And you could represent a piecewise function of how many ever number of pieces you have as a single function based on the corresponding step functions being turned on or off at those respective times. Okay. So the main results we derived yesterday were the Laplace for the Heaviside function being e to the power of negative as over s. Again, we're going forward in time, so we are never encountering a situation where a is going to be going backwards. Okay. And the main application of this function is if you want to delay your input by a certain time, okay, instead of applying it from t equal to 0, it helps you solve those problems without breaking your differential equation down into bits and pieces. Okay, so it kind of helps you do everything together. And the Laplace for this delayed function is given by this term here. I think I wrote this a couple of times yesterday. It's not equal to the product of the individual Laplace transforms, okay, because of the way we derived it. And this works both forward and backwards. So if you want to go from here to there when you're solving a differential equation, okay, the key thing to keep in mind is that your f of s is going to change in f of t and then shifted by whatever amount you have for the value of t. Okay, so the same amount of a here should be delayed here as well. So, and you will see that when you look at the answers for all these problems, you will see the answers are all kind of delayed by that t minus a. Okay. So that's where we stop. We're going to do a bunch of examples today, and on Tuesday I'll introduce one more function which is going to make this even more interesting. Okay. So that's where we stopped. But more importantly, there is a test today for 99% of you. Okay, I think one of you have already written it. So, and there is no lecture on Monday and no office hours on Monday as well. Okay, unless you really want to talk to me on Memorial Day, I'll try to take my day off. And next test would be based on chapter 3. So it's what we are doing right now. Okay. Any questions about anything before we start with today's lecture? All of you are aware of what is going to be in today's test, or are you still kind of in the dark? Any good? Okay. Okay, so we'll do a few examples today. I'll stop by around 8:30. So solve the initial value problem. Y double prime minus y prime minus 6y equal to 2 ut minus 4, where y of 0 equal to 0 and y prime of 0 equal to 0. Okay, so the only difference here compared to 3.2 is that right hand side has some kind of a step function. Okay, the meaning of this term is that your f of t, the non-homogeneous term, it's equal to 0 for t less than 4, and it's equal to 2 for, that is the meaning of that function. So if you were doing this without Laplace transform, you have to kind of break it down into different intervals and do it separately. Okay, this helps you do it everything in just one shot. All right, so most of the steps are pretty similar to what we were doing in 3.2. So take the Laplace transform from left to right. So it's going to be L of y double prime minus L of y prime minus 6 times L of y equal to 2 L ut minus 4. So in this problem, the initial conditions are equal to 0. Please don't assume these are always the case. Okay. Read the question. They're not 0. It's a small inconvenience because there are more terms to solve for. Okay. But here they are equal to 0. It's a pretty straightforward process here. So s square y of s minus sy of 0, that's 0. And then you have minus y prime of 0, that's also 0. Okay. Minus s times y of s minus y of 0, that's 0. Minus 6y. So you're going to recover your characteristic equation that you would usually see in chapter 2 when you write these terms with capital Y of s. Okay. And that's equal to 2 times case number 11, that's going to be e to the power of negative 4 s over s. So don't forget this denominator of s in this one, okay, because that's what I had for case 11. Okay. There is another function which is case number 12, which we haven't done, that does not have a denominator. So when you look at these things, you should look at the right line. Okay. All right, so let's do it a bit inefficiently here. I forgot to tell you that I think somebody fixed the camera, so hopefully today's video quality is slightly better than yesterday or much better than yesterday. Yeah. They said something was wrong with the focusing of that. So, all right. So let's solve for y of s square minus s minus 6 times y of s equal to 2 e to the power of negative 4 s over s. Divide both sides by s square minus s minus 6. So y of s equal to and all those algebraic things we have done so far, they are still applicable here. Okay, so always ask the right questions here. Can we factor this? I hope you can. Okay, at least that's what I was planning to. So I hope you can factor this. Okay. As s minus 3 times s plus 2. So it's going to be, and this is the place where you just need to be a little bit more organized. Keep that e to the power of negative 4s outside, because that shouldn't be part of any of your partial fraction or anything you do. Okay, but you shouldn't miss it. So just keep it clearly spaced here. Divided then times 2 over s times s minus 3 times s plus 2. Whether this 2 here is helpful or not, I don't know. Okay, just keep it there. Oh, didn't go all the way up. Okay. I forgot, did I start recording this? Okay. All right, so let's do the partial fraction for 2 over s times s minus 3 times s plus 2. So we did case with 2 linear terms. If there are 3 linear terms, you just need a third extra term on the right hand side. So it's going to be a over s plus b over s minus 3 plus c over s plus 2. Okay. Clear the fractions. And you get 2 equal to a times So you're going to multiply whatever terms which are not in the denominator. Okay, so it's a times s minus 3 times s plus 2 plus b s times s plus 2 plus c s times s minus 3. You know what to do. Put some nice numbers in here. So s equal to 0 would shut off the second and third terms. That gives you a equal to negative 2/6 or a equal to negative 1/3. I've kept a 6 on the left hand side. Too late. S equal to 3 will give you b equal to 2/15. You know if I'm messing up any numbers here. Okay. And s equal to negative 2. This is the one I'm writing about. S equal to negative 2 will give you negative 2 times 3 is negative 5. One-fifth, is it? Ooh. All right. Okay. It's one of the reasons why, when I make exams and everything, I go out of my way to have clean answers so that it's easy for me to look as well. Okay. I don't like fractions. When I get a pizza, I eat the whole pizza. Don't cut it up. All right. So this is back to y of s. Okay. Don't forget your golden term there, e to the power of negative 4s. So, and times this set of terms, which is negative 1/3 over s plus 2/15 over s minus 3. Plus 1/5 over s plus 2. Okay. All right, now it's time to invert it. Okay. So in 3.2, you would have inverted these kinds of terms. The only difference here is this thing sitting here, which should be a reminder of the second shifting theorem, which I had somewhere here, erased it. Okay, but so y of t is the Laplace inverse of this whole thing. Okay. It's what we are trying to find here. Remember that from the second shifting theorem, E becomes U, okay, because it goes back and forth. So it's U of t minus 4, which means that this output should not start until you hit t equal to 4, okay, because your input started only at t equal to 4. This has to be delayed as well. Times, this is case number 1. There is nothing to shift here, okay. Once again, it's a constant. A constant term is kind of not disturbed by the fact that t is there. Okay. Plus 2/15 e to the power of, this would be usually e to the power of 3t, but in this case it's going to be 3 times t minus 4 because of the second shifting. Okay. That's this. Can somebody tell me what the last one would be? 1/5. T minus 4. Right? And you don't have to multiply this inside and make it worse. Okay. So but what is easy to see is if you just write it in this form so that I can see the shifting part clearly written out. There is no need to write as negative 2t plus 8 and so on. Okay. So that is your final answer. Once again, in terms of what this means, okay, this is making sure that the answer or the output to this external force coming in, it's not starting till you hit t equal to 4, okay, which makes sense because there's nothing to start with anyway. So most of these questions have a very repetitive nature. If you get used to this process, chapter 3 is a piece of cake. It just keeps on coming one after the other, just different numbers. Any questions on this example? All right, so let me write down a spring mass problem and ask you to do it yourself. Number 2. A spring mass system with no damping. Let's start with easy things. So no damping first. Has m equal to 1 and k equal to 4. Let an external force f of t equal to, so I'm giving it as a piecewise function. Okay. It's equal to 1 for 0 less than t or less than or equal to t less than 2 pi, and 0 for t greater than 2 pi, which means that I'm keeping that force of 1 unit active only for the first 2 pi units of time. After that, I'm shutting it off. And suppose the system starts from equilibrium. Which means that the initial velocity and displacement both are equal to 0. Okay. Solve for the displacement. You can use x or y, I don't care. So since we are doing everything in terms of y, let's just use y. Solve for the displacement. Y of t. That way I don't have to kind of rethink about Laplace transform in terms of x. So the system looks like this. We have a differential equation which is mx double prime plus k, my double, old habits, my double prime plus k times y equal to f of t. Okay. That is the differential equation that governs the system. The only problem is that this f of t is a piecewise function. And that's why we learned all those techniques to convert this into a step function yesterday. Okay. The easiest thing to do here would be to rewrite this in terms of your step function using that long equation we had. Okay. Only 2 pieces here, so you don't need to write all the terms. So this is your f1 and this is your f2. Okay. And once you do that, this equation is kind of similar to the earlier problem, kind of similar. Okay. So this is f1 plus u of t minus 2 pi times f2 minus f1. So f1 is 1 plus u of t minus 2 pi times 0 minus 1, that's negative 1. Okay, so I can just put a minus 1 here. So the equation now looks like this: y double prime plus 4y, because I have k equal to 4 equal to 1 minus u of t minus 2 pi, with y of 0 equal to 0 and y prime of 0 equal to 0. So you need to be kind of comfortable doing this process here. If you're given a piecewise function, you should be able to write this in a form where you could take the Laplace transform easily instead of doing unnecessary integration and so on. Okay. That's the only part which is kind of different in this problem. Once you are here, now you can start solving it. Can you go ahead and do the usual process? Take the Laplace transform both sides and see what happens. Okay, so L of y double prime plus 4 times L of y equal to the Laplace transform of 1, okay, that is not 0, minus the Laplace transform of u t minus 2 pi. Once again, it's starting from equilibrium. Okay, so that kind of makes our life a bit easy on the left-hand side. This is just s square y of s, y of s. There is no s for the L of y term. Okay, some students, they put that there and end with all kinds of weird things later. So this is just 4 times y of s. This is case 1 over s, minus case number 11, that's e to the power of negative 2 pi s over s. Remember that we are expecting oscillations here. Okay. It's a spring mass problem. We are applying some initial force that should set this moving. Okay, so at the end of this problem, we need to get sine or cosine or something. All right, so this is s squared plus 4 times y of s equal to 1 over s minus e to the power of negative 2 pi s over s. Divide both sides by s squared plus 4, and you get y of s equal to 1 over s times s squared plus 4. Once again, I'm just going to write it in a way where this term is not going to affect anything else here. Okay, times 1 over s times s squared plus 4. The good thing here is that we have the same term on these two blocks here. Okay, 1 over s times s squared plus 4. So you just need to do one partial fraction for each, but after that you need to be careful. Okay, this needs to be shifted, this does not. Okay, so you need to be kind of aware of what's going on in each term. But let's do the partial fraction first. Partial fraction for 1 over s times s squared plus 4. And I write this. Anything wrong? Everything is wrong. Okay. BS plus C. Not everything is wrong. Okay, so please be careful at that point. Okay, just focus. It's not B over S square plus 4 and not even B plus C, it's BS plus C. Okay. Clear the fraction. So it's going to be 1 equal to 8 times S square plus 4 plus S times BS plus C. Okay. You can do whatever method is comfortable for you to solve for ABC. Okay. I usually prefer putting S equal to 0 to find A, then A is 1/4. And for the remaining, I would just expand it out and compare the coefficients. Okay. So 1 equal to, this is A square plus B square, that is A plus B times S square. Again, you may have other techniques for doing this, so feel free to use whatever you like. Okay. Plus 4A plus CS. And there is only one term on the left-hand side, so A plus B is 0. There is no S square here. Okay. And C is also equal to 0. Now, this does not mean that both A and B are 0. A is 1/4. Okay, so B is negative 1/4. We shouldn't get all three letters equal to 0. That means something is not right. Okay. So C is 0, A is 1/4, B is negative 1/4. Any questions up to there? Everything going okay? All right, so let's now write that down into our YS term. Okay. What is it? Right there. So that's Y of S equal to, I'm going to write something and you need to tell me what mistake I made in this process. Okay. So A is 1/4, B is negative 1/4. Okay. And this is a mistake that 75% of the students make on the first quiz or test they write for this topic. Okay. I think you saw that. So that's minus e to the power of negative 2 pi S times 1/4 over S minus 1/4 over. So now there are two mistakes. So can somebody online, I think somebody here already told it, but can somebody online tell me what is wrong with, it's not fully wrong, but something is there, missing there. What is that? The S term, okay. I know it's very easy to kind of just copy these values into the wrong places. It's BS plus C, not B plus C. So if C is 0, you still have the B S here, okay, and S here. So nothing should just disappear. Yep, so nothing should just disappear by magic. There should be a reason why something should just go away or everything else should be remaining there. Okay. All right, so let's now start inverting this. Okay. So Y of t is the Laplace inverse of Y of S. These two terms don't need any shifting because there is no e to the power of negative as multiplying these two. Okay. So no shifting for these two. Shifting should be done only if there is a term like this multiplying it in front of it. Okay. So these two need shifting. And that's because the force started from t equal to 0 and it kind of terminated after t equal to 2 pi. Okay, so the problem will start with something and will kind of change after 2 pi. So this is going to be 1/4 minus 1/4. The Laplace inverse of s over s squared plus 4 is cosine 2t. Okay, and there comes our oscillatory term, right? Minus e becomes u. Okay, so it's u of t minus 2 pi. So here the force is shut off later, not starting from with 0 and bringing the force in. Okay, that's why the shifting term is appearing later in the solution. So it's u of t minus 2 pi, 1/4 minus. Can somebody online tell me what the next term would be? Just unmute and. Nobody wants to. It should be pretty similar to what I've written here. Yeah, go ahead.
Should it be 1/4 cosine 2t?
1/4 cosine 2t. Well, that's perfectly right. But you probably had something like this to start with, right? Oh, this is what you would have written first, because you have cosine of 2t and then you have to shift it by 2 pi. But then because of our magic property of cosine, you could write it as cosine of 2t. In this case, that will be right. Okay. So cosine of 2t minus 2 pi is the same as cosine 2t because it's a periodic function. You cannot do that if it was an exponential function. Okay. For this case, even if you meant to write it or not, okay, cosine 2 of 2 times t minus 2 pi is the same as cosine 2t. So this would be 1/4 minus 1/4 cosine 2t minus u of t minus 2 pi times 1/4 minus and it's okay if you leave your answer like this. Okay, I don't expect you to do this simplification each time because it's something that most students kind of forget after the high school. That's a periodic function. So even if you leave your answer in this form, it's okay. Well, the answer looks a bit weird because of the step function. Okay, just to understand the meaning. So this is the final answer if you want to stop here. But those who are curious about what that means, the meaning is for t less than 2 pi, that is when the force is active, u of t minus 2 pi is 0. That is when these two terms are there because there was a force to start with. Okay, so f of t, y of t is 1/4 minus 1/4 cosine 2t. And once the force is turned off, okay, so for t greater than or equal to 2 pi, u of t minus 2 pi is equal to 1. That is what the step function does, right? 0 or 1. This becomes equal to 1. Okay, and look at what happens. You have 1/4 minus 1/4 cosine 2t minus 1/4 minus 1/4 cosine 2t. What is that equal to? Are you seeing what I'm saying? Or what is that net thing equal to when this becomes equal to 1?
0.
0. No force, no motion. Is that right? Or am I missing something? A lot of negative signs, eh? Okay, but then I don't expect you to dissect it and write a meaning and everything. Okay, that's just for anybody who is curious about what exactly is going on there. This is the final answer for our purposes. All right, perfect time and place to stop. You can do your homework in 3.3 and 3.4. Just avoid this creature for now. Okay. We'll talk about this creature on Tuesday, and after that you'll be kind of fully prepared for chapter 3. All right, so don't forget your test today before you take off for the long weekend, and have a nice long weekend. Okay, so take some time off and enjoy.
Thank you.
Thank you.